A fish stock is like any other population. To maintain numbers, there needs to be new births or recruitment, the addition of young fish to a stock. Balancing numbers going out, deaths, with numbers coming in, recruits, is a critical process for managing fish stocks. In this section, we'll examine reproduction and recruitment and the key information scientists require for their stock assessment models. Obviously, not all eggs that are spawned end up growing into fish that will recruit into a fishery. Many die on the way. So, in our diagram, breeding and recruitment are inputs into biomass change. It's important to remember that for most fisheries, there's no way scientists can count all the eggs or offspring produced by a fish stock. It's just physically impossible. So, how then do they go about measuring it? Scientists usually assume that the number of eggs produced by a fish stock is directly related to the total weight of all the mature spawning fish. It makes sense. The more adults there are, the more eggs that can be produced. The starting point then is to work out when a fish becomes mature. Like all animals, fish species vary in the length and age they become sexually mature and can breed. In our case study fisheries, tiger flathead and gummy shark all mature at about 4 to 5 years old, southern bluefin tuna and blue-eye trevally at 10 to 12 years old, and southern rock lobster at about 7 or 8 centimetre carapace length.
The minimum size for the females is 105 millimetres carapace, which is the back of them. The males is 110. They reckon that when we start to take the females, they're about 5 to 7 years old. The males about the same. And they think by the time we start to take the females, they've had about 2 years of spawning.
Working out the age of fish is very time consuming and expensive, and for southern rock lobster, it can't even be done. So instead, scientists look at the relationship between sexual maturity and length. This is much easier to measure. The most efficient method of doing this is to examine a commercial fish catch and work out which fish are sexually mature and what their length is. From this, scientists can estimate at what length the average fish of that species is sexually mature. So, why is length at sexual maturity important? The answer is that with information on the distribution of fish lengths in the stock and knowing the average length at which they begin to breed, then scientists can work out the amount of breeding individuals in that stock. It's called the spawning biomass. Working out the length of the fish in the stock is not as hard as it sounds and is covered in more detail in the next section on age and growth. The relationship between the weight of the breeding stock and recruits into the fishery is usually estimated by the stock assessment model. This stock recruitment relationship, or spawning stock recruitment relationship, is one of the key bits of information that describes how recruitment varies in response to changes in fish stocks. Having said that, this relationship is one of the most difficult things to directly measure, so scientists make certain assumptions about how the relationship works.
Believe it or not, one of the advantages of fishing down stocks is we actually learn quite a bit about them, and from stocks that have collapsed, we've found quite a bit of information about to what levels the parent stock can be fished down to before it collapses. This is known as stock recruitment, and through this happening in various places and different species around the world, we've seen that different types of fish have different stock recruitment relationships. Some stocks, you can fish the parent stock down very hard and not necessarily see a lack of recruitment. With other stocks, however, we can see that fairly light fishing on the parent stock, you can notice a change in recruitment. What this enables us to do is to use the information that's been gained from other fish stocks and apply them to fish stocks that are very similar. So what generally happens is we use the best stock recruitment relationship we have and apply that in the assessment model. The thing is, it doesn't stop there. We then use the assessment and we test out various different stock recruitment relationships and see which fits the data best. That way we can get a certain amount of comfort that our stock recruitment relationship is right for that species.
Now, length at sexual maturity isn't the whole story, because the bigger the fish, the more eggs it produces. A good example of this is the southern bluefin tuna. On average, a 115 centimetre southern bluefin tuna produces about 870,000 eggs, but a 130 centimetre tuna produces over 2 million eggs. Fish have an incredibly diverse range of breeding strategies. Tiger flathead, blue-eyed trevally and southern bluefin tuna, for example, are broadcast spawners. This means that eggs and sperm are mixed together in the water and grow into larvae. Gummy shark internally fertilise the females and give birth to live young. Southern rock lobster, on the other hand, use a totally different strategy. They fertilise eggs externally and hold the fertilised eggs under the tail of the female, and after they hatch, they swim off into the plankton. Because scientists can't measure the number of eggs or larvae, the first time they begin counting most fish is when they are recruited into the fishery. Recruitment into a fishery occurs when the fish reach a certain size and are available for catching. The length at which they are recruited is determined by the selectivity of the fishing gear, the growth rate of the fish, and sometimes the behaviour of the fish. So that's about it for recruits. In summary, this section looked at the importance of finding out what age and size fish start breeding, what recruitment is, and the assumptions used to describe recruitment. In our next section, we'll be looking in detail at how scientists age fish and measure growth.